It is a very interesting time to kind of enter into data engineering. My theory is that if you see the industrial evolution kind of happen over the period of a time, especially the textile manufacturing side of it, obviously hand looming kind of gave away with the industrial scale manufacturing. But we manufacture a lot, we employ a lot more people, but it's a different skill set completely. Same way, the Gen AI will accelerate the way that we are building the data. The more and more industries will start to use data. Otherwise, if you are doing a hand stitching of all the data modeling, may not be possible. So you will see a huge demand more and more. It's just a different way of workload. One of the bigger challenge in data engineering space is like
Welcome everyone on this episode of Let's Talk AI. Super happy to be here today with Ananth Packkildurai. Ananth, how are you doing?
hey, I'm good. How are you?
I'm doing great. I have, I think I say too much, but I have a lot of questions for you today. And I think this episode is going to be a lot of fun. We're going to speak startups, founders, building products, shipping fast, data engineering, data observability, and more cool things on the way. So maybe for the people who might not know you, could you maybe in one or two lines introduce yourself?
Oh, yeah. So, hey, hi everyone. Great to be here, and thanks for having me, Thomas. My name is Ananth Packkildurai. I'm a typical data engineer who loves just moving around data from one S3 bucket to another S3 bucket. That's what I do all my life. I'm very passionate about the intersection of how data is kind of powering new analytics and kind of paving the pathway of new wave of knowledge mining with all the Gen AI stuff that's kind of going around the world. I'm also the author of a data engineering weekly newsletter. It's kind of an aggregated newsletter for you to bring current trends and patterns that people are solving the problems. So that's a little bit about me.
Awesome. Amazing. I always like to do two questions at the beginning. The first one is your state of the art, and the second one is a retrospective of what you've been doing um, since you started, just a key insight. So, what do I mean by the state of the art? I mean, what are you currently excited about, or what are you currently working on, and like, what is your drive or your mission, or what are you trying to achieve at the moment?
So at the moment, I think we are in a very, very interesting intersection. Gen AI kind of really helping a lot, especially around the way that we code. There's a certain shift in the behavior that the programmers are trying to do. Is more how can we use an extension of um, you know Gen AI side and all those LLM that is kind of providing us. Now, my question is like, okay, what does that really mean for data engineering space? There's a speculation that many kind of the machine can write a SQL, and then you don't need to have a data engineer. Like, I have a very different view from the historical perspective. So I think I'm very passionate about in this area where and I'm expecting more and more challenges and all the old dynamics that we've been seeing so far going to be get challenged. If you are starting data engineering space, I think this is a very exciting time to start, in my opinion.
Awesome. Thank you. And going to the retrospective, can you share maybe, since you started your journey, like key moments that you kept from specific experiences that can help us um, trace a roadmap of what you've been doing through these years?
Yeah, totally. I mean, I started my career typically like in a backend engineering space. I'm one of the unfortunate victim of getting carried away with the buzzwords of big data and Hadoop, where I started my journey when Hadoop came around like 0.20 version of it, and then so I started working on Hadoop at the time. That is when I started getting introduced to data engineering space. If you are a backend engineer, it's very easy for you to get transition to Hadoop, because at that time you have to write like huge chunk of Java program to build your MapReduce applications on top of it, right? Um, I think that's when those Hadoop kind of started to evolve, you tend to evolve on top of it, where it get introduced to Hive and SQL, and how do you structure your data? How do you properly organize, and what is the importance of organizing the data rather than putting their muscle power on processing a lot. So that's how my journey kind of continue. Like if you just follow the big data to Hadoop to modern data stacks to the current state of engineering, that is what my journey is all about. Like evolve the nature of the system more, focusing on the modeling, minimizing the number of data processing, like minimizing the number of data that we are processing. That's what the whole uh, progress of the data industry from the Hadoop world. So that is what mine. So being there, and I think um, I joined Slack around 2016. That was kind of a very great experience for me. Spent around 4.5 years. Started very early in as member of the data engineering team. Helped to build the data infrastructure side of it, and work a little bit on the monitoring observability side of it. When you have this hyper growth company and then you are in the leading seat of it, you get to know how do you build a system that can withstand, that can scale, and not the textbook style architecture is not the best all this time. Like it just like can it make it work? Like just good enough architecture is always win. And after Slack, I spent time in Zendesk and Moral. Zendesk is an interesting company that is kind of grown by acquiring companies. So you will see like multiple same ecosystem across different teams. So um, and Moral is like kind of a very small startup. Like you tend to like like less maturity on the data side. Like how do you kind of see through the people are viewing this on. So collective all those experience, I feel that's essentially my career trajectory. Gone from like a very hyperscales to desperate ecosystem to a smaller startups side of it, and then seeing how the data being used across different nature of a business and different state of the business. Essentially.
Great. So there are multiple things that I'd like to tap on. I think that you touched an interesting point, that all engineers talk about all the time, which is scaling. And so I feel that the scaling word comes back a lot in different systems, and maybe there is an argument to be made where like a lot of people worry about scaling when in reality they don't need to think about it at that point. But I'm super curious, maybe if you could share some insights. You mentioned so what I really like about your background is that you've been from the beginning with like big data, Hadoop, Spark, and like you follow those technologies. So I think that you have a very strong understanding of what scaling, like how scaling things, tools, technology have changed through the past, I don't know, 15 years. Um, and so maybe you can share some insights regarding your time at Slack and like what does it mean to scale in the real world, and like what are some challenges that are not obvious that you've seen, and how you manage them.
So yeah, back in 2016 is around the time like Slack was kind of growing very fast, right? Like I mean we are creating new customers. Like a lot of it's kind of a pretty popular tool at the time, and any downtime in Slack is kind of a TechCrunch news, right? Um, and um, and then we have a limited number of people. In a scaling law is always like there's a people time, and how much money that you can spend. There's always a trade-off between all those things. Even if you're growing very hyper fast and getting a new person on board to the team and train them, it's like it takes like 3 months to do that one, right? Like even regardless of how experienced you are, right? To getting understand the existing ecosystem. So that also take a toll for them. So it is important to kind of understand what is the immediate need, and what is the future direction going to be look like, and then making the architecture is always like I don't believe there is like a perfect architecture or a textbook style architecture or a clean architecture that people write in the book. That will not work in a real world, right? I give an example is like when we started using Apache Airflow at the time. It was like 1.6, 1.7, and the scheduler had a lot of bugs, and the community since now then kind of fixed a lot in this case. Um, and for a lot of people to surprise, we've been running Airflow in a single node, single like a local executor up to like I think around like 600, 700 DACs been running in a local executor in one single machine. And we know that is not the right scalable architecture. We know that we have to go to a distributed execution system. We just don't have a time and people, because we have other part of the ecosystems also growing. Orchestration is one part of it. You have to build your query engine. You have to build your big lake house that you are doing, that you have to bring the data, you have to manage your Kafka clusters and all the other aspect of it, right? So now, given all those constraints, what are the best possible way for you to take to um, make a decision, just keep the system running, to give some time to kind of think about going to a distributor style, right? So we did a lot of optimization on running a local executor. Um, we did an internal retry sensor that essentially we found out like Airflow creating a new wait for sensor and just hanging in the process, and that killing the CPU overall. So we just had an internal retry operator that, if you don't have a sensor, it just die and then come back and try to retry again on those things. That pattern then kind of adopted by the Airflow ecosystem. Now they kind of adopted the retriable sensors in a way. Um, and as a single team, we cannot build all the DAGs. So you have to build a framework quick enough that you allow everyone to build DAG around you, right? So we build um, a lot of CI/CD abstractions, like, oh, you are a production DAG, and if somebody committing a code or somebody creating a new DAG, whoever, it could be a developer, it could be a business analyst, it could be a data analyst, they had to adhere to certain standards before committing the code.
Mm-hmm.
So we largely focusing on building that framework, making it scale just enough to make everyone usable, get the tool, get adopted. We didn't spend time on, okay, we have to build a distributor system, let's do it in the right way. Once we get more and more adoption of the tool, then we started focusing on, okay, Lord, what, like, we eventually migrate to a distributed execution model. But the critical part of any internal tools or any tools that even a product, the scaling law is always like, get the users to get adopted. Don't solve an imaginary scaling laws first. Getting this tool adoption, and how do you get more ease of use is what really critical, before you're really thinking about the infrastructure scaling side of it. Often engineers tend to carry it away with, I wanted to build this infrastructure first, and then the users will come. It should be it's the other way around. So that's one of the hard lesson I learned out of it.
All right, makes sense. I have two questions from that one. One on the side of feature prioritization. So there are a lot of methodologies that can be found out there. So I'm super curious to have your approach on how do you estimate the value of doing the right feature at the right time. Like, how do you estimate having a framework, like, okay, we're going to spend X extra time here to have this framework because this is going to be the most this is this is going to give us the most leverage. So that's one part of the question. Like, how would you approach that? Is it do you have specific frameworks that you really like, or maybe you just expertise plus intuition plus some combination of tools? And the second question will come after, but I'm curious about one of the biggest challenges that you've seen, like scaling with a single team, a tool like Slack in the beginnings. I don't know. I think there is some interesting things to say here. But first of all, yeah, if you could share maybe some best practices regarding feature prioritization.
Yeah. Feature prioritization is a very interesting aspect, right? Like, I think the simplest framework I believe like everyone is using in the industry is, I think, kind of is a very proven technology. Is like the effort and the yield, the combination of like what is a so if you are doing, so ideally your team should spend more on low effort and high yield projects, right? That's a sweet spot for every organization to be there, right? You took like 1 week time, but the yield that the consumer is going to get it or the customer is going to get it is like a pretty high. It's a very sweet spot to that one. You don't want to be in low effort, low yield project, because that sometimes is necessary, but you aggressively kind of deprioritize, right? I think so. The high yield, like, so if you do like a typical square stuff of like a Venn diagram kind of a thing and say like, is it a low yield or low benefit project versus low effort project versus it's a high yield high effort projects. Like for example, if you take an airflow example, if you go with a distributed system, it's a high yield because now we're able to scale more and more, but it is also high effort. The high yield, high effort project is often where the innovation or a new framework or 2.0 that you are rewriting, that you are breaking certain things. That sometimes often means pause the thing that you are doing for a certain period of a time for users because you will putting a lot of efforts on that. So taking that strategic, that essentially became like a strategic projects. Taking those strategic projects in a way that it gradually progressing versus high prioritizing more of a low yield high low effort like high yield projects. That is when you will get a maximum benefit out of it. I mean, it comes from like your degree of understanding about your domain, your degree of understanding about your customers, and your north star vision that what you are going after it. I think that kind of a framework really help people to envision about it.
I see. And follow up on this one. How do you quantify the customer yield or like the effort that needs to be put in? So like, do you follow a specific tech? I don't know, just things that I've seen recently. I just look at estimated hours of back end, front end, UI, architecture, or maybe like specific things that we know that, I don't know, correlations between features that are important. For example, if I solve this, well, it will have impact on the three others. So this does, maybe this is a like low effort, low yield, but it is connected to three other features that are important and that would become, I don't know, high yield, low effort, but they are currently high effort. Like correlations between features and how to quantify this to like be able to discuss on. All right, I believe that this is high effort, high yield. Even though I totally get the point where when we target high effort, high yield features, we can go incrementally with them and see like how far do we want to push it. We don't need to have everything, but maybe the first pieces would get us in the way, and then we use data to optimize the future prioritization. But I wondered if you had some further insights on this point.
Yeah, it's a very interesting question, right? So I've seen one of the things that many of the internal products for internal tools people are making is that, to your point, is thinking thinking everything as a project. And so when you are thinking everything as a project, then you are thinking more on an isolated way that, oh, this is one of the task, another task. Like when the moment you start to think about like a project and a task, that's where you will get end up with like all this kind of a question. But if you start with a thing like you are building an orchestration engine, which is your product, yes, it is getting used by the internal users. Now, what is the nature of an orchestration engine? What are the features that we are building more on top of it? Like thinking in terms of the product rather than projects and the task. Moment you started to switch your mindset, like underlying, even though you are doing a similar prioritization, now you have a similar features to group together. So now that essentially kind of answer your questions around like, okay, I wanted to deliver this project. These are my prerequisites for me to deliver the project. Now your weightage is always based on the features and what is the important, what are the important milestones for this project, these features to get delivered rather than individual task to be get delivered, right? So I think that product thinking internally is really helpful for you to get more and more data platform adoption available there. And I think that shift is happening in the industry a lot. I can see a lot of product management role is coming in the data engineering space. Like you can see like a lot of data product managers, because engineers are like not so well equipped to talk to the customers and like the internal stakeholders. um, I think getting the product thinking in data engineering space is very important.
Yeah, and that was exactly my follow-up question, which is how do you make sure, because once you know which features to do and like you can create sub features and and you know the nature of your products, and so you can have a big idea of like the core features that you need to do, and then you have different frameworks when you can have like must have to the delight features and so on. You can classify them, but previously to that, in your experience, speaking of product managers in engineering, in data engineering, or in software engineering, or in just in tech in general, uh, what are the best processes that you've seen where they continuously capture the needs of the users so that you can more efficiently calculate these yields? Like, do you have insights maybe on how doing this very well, like at the high level, looks like?
Yeah, totally. I think um, I have seen very successful product managers in the, especially in the data space, doing two, three things very well. Like one is like constantly talking and interviewing the customers. When you specifically take a data engineering space, right? There is an analytical engineers or business analysis who actually the power user, they are querying your system, and there is like a data scientist. And then there is a business user, there is a software engineers are doing. Not everyone are the same. They are very different customers, and they have a very different need. Some need like a I like some people will say like, I want to write a SQL query. I wanted to understand what is the root cause of this particular metric is not working fine. I wanted to get the raw data access for me. Versus the business, say like, hey, I don't really care where your data is there. I just want to get this insight. Can you give me this metrics? And can I trust your metrics? There are different customers and different personas and different need, and then talking to them to kind of understand what is the really need, and then trying to understand the pattern across the different user persona. So a good product manager in a data space have a very clear distinction of like what are the different roles and what are the different persona associated they are using the data platform, even though it is same data platform underneath it, right? The second thing is like not only asking them, but also kind of understand what they're trying to do behind the scene. One example is like, some product managers take, hey, I wanted to understand these are the business users you are using Tableau. Can you figure it out, Mike? What are the tables they're frequently querying, how the SQL is kind of structured, and what cadence they are doing it? And oh, they're doing it like every 24 hours or Monday morning. Can we cache the data Sunday night? So they don't need to query us, like, you can quickly serve the users, right? So understanding the behavior, understanding the need, understanding the patterns of different personas, bringing that thinking back, and then say like, hey, this is what people are doing within ourselves. Can we build a data platform for that? Uh, I think that a thinking and that kind of a mindset on customer focus to build the data platform is what often very successful. Those teams are often very successful in driving a data-driven organization culture, essentially.
Mm, makes sense. Thank you very much. That's very clear, and I can really see how you have the persona, you have their need. Like when you do the interviews with users, you not only ask them what do they want, because they want not necessarily, but what are you trying to achieve, so that you can think of the best way to implement it, and then afterwards you can use your own data to like check the personas and the patterns that you've identified from those interviews with users, so that you can take the best decisions regarding your product.
Golden rule is like users always lie. So that's what it is. So don't trust what they say, just see what they're doing.
Yeah, I love this one. Yeah, totally true. I feel like this applies to more than users in general. So if I come back to the so just to close maybe the Slack chapter, I was super curious if you had maybe one or two of your most biggest challenges that you faced, from an engineering perspective. I don't know, in scaling, or like, I don't know if you have a short story of something that engineers like to hear. I don't know, maybe like how was it at the beginning, or a specific problems that you really enjoyed solving. I don't know if you have any insight on that one.
I think the bigger challenge for me, or like it's a combination of effort. Like when you're in a when the company is kind of growing very fast and the product usage is getting fast, now you have to scale, and also you have to keep the lights on. You cannot, you cannot say like, okay, we're going for 3 months hypernet. We're not going to build any feature for that, but we are going to build in a right scalable architecture. That is very very hard for, like, one example is like one of the challenge that I've seen is to kind of build the search infrastructure, right? So Slack kind of producing all the messages. We have to index the data into a search engine so that people can go and search. Like you can see the search box on top of it, right? Now we constantly change the relevancy score and then, like, adding some more ML algorithm to kind of help the customers to kind of find the relevant information, because that is what Slack stands for. It's a searchable log. I'm not sure how many people are aware of the acronym of it, right? Now, when you want to do re-indexing and you want to do a re-ranking and all those application, then you have to reprocess the whole messages, and then you have to reprocess all the thing. So now you can see this scale of Slack, but the messages is kind of an activity, right? Like you just type, that's the way you are working. That's where your work is happening. So how do you build a re-indexing algorithm where you kind of build all the giant indexing top of it? And we started that project, and like within 3 months we got IBM signed up. And IBM is kind of like, oh, we wanted to onboard, like, all our 500k employees into a Slack channel. I was like, wow. And like, so you will see all sort of, this is true for most of the enterprise companies that I have seen, not only in Slack. I've seen the same thing in Zendesk and Moral and other companies. It's like two phenomena that is unique to enterprise companies. One is like the skewed customers with a whale customer kind of a model. Essentially, like you'll have 10 customers or like very, very heavy power users. They generate tons of usage, and you will see like a chain of tail of small customers. They have like a smaller usage, but still very important to them, right? It is not like their usage is small, it is not that important to them. It just their volume and the scale is pretty small, versus an example of, like, typical example like IBM has, like, and then you have a community Slack, which is pretty important for community. You have like maybe 50 users in a community channel is very important. There's 500k in one particular channel, right? Similar in Zendesk, like you have like a tremendous support ticket system coming in one particular system where your whole ecosystem is operating on that, versus some small startup having two customers and create Zendesk. The tool is all the modern SaaS tools now is kind of tuned for like high scale and the low scale system, which more of a value proposition they are adding that on. I think that's one of the challenge, like, distribution and skewed, and how do you structure your data processing in a very intelligent way to handle those two customers associated with that one. The second aspect is that the what I call is the 8 a.m. syndrome. What is that 8 a.m. syndrome? Is like, I know 8 a.m. PST is where you will see East Coast in the US, West Coast in the US, and the Europe came online to work. That's the only time that's kind of polluted. And many enterprise companies, if you see like 8 a.m., your traffic will be spiked like this. So and this is like a very abnormal spike, right? First time, and then you just gradually. So like majority of the days, like your workload is stable, and you'll see the sudden burst in 8 a.m. So that's another interesting infrastructure challenges in the data processing side of it. Like you suddenly in 1 hour, like if you're dialing a daily processing pipeline, suddenly in 1 hour you'll process like 3x amount of data, and then you do this one, like, how do you do that? So the variability and the variations of the customers are like very unique to the enterprise companies, and which is like, you can think of like it's the order of magnitude amplified in Slack. I think that's a bigger challenge.
Yeah, that's super fun to hear. Yeah, like this. Yeah, auto scaling. Go, go, go. Just Kubernetes cluster. Go, go, go. Everyone, go. Let's put full power here. Amazing. Yeah, I can only imagine how fun it is to have like the first time that you have a client like IBM, for example, or like huge demand of users, and the system is not ready, but it will need to be ready faster. That's those are like fun situations to be in. I'm going to do a transition from this data engineering, software engineering landscape to observability. And here maybe we can comment on the books that you wrote. Um, Maybe we can do a short like what's the data engineering for you? Like what do you want to share through the book, through your posts, LinkedIn's, and so on. But my idea behind this question is to understand how do you connect data engineering with observability, and how did you get interested in observability in the first place?
Yeah. How do I got it introducing? I think, I mean, it's not like purpose. Like, it was like I didn't have a good relationship with the observability team at the time. I was spending hanging for some time. We were co-creating some of the components, and I happened to work on a lot of their ecosystem gradually, and then moved on to the observability team. But I think it is kind of one of the very important thing happen in my life. I think in my career, essentially, right now, I highly recommend everyone to take some time to work on the observability domain. What observability essentially gives you is a very it's a great fresh view on the system that you are building, right? uh, there is a certain system that you're building, and you're kind of observing from that other point of view. Now, when you started to build a system from an observability perspective, you will build a much more reliable system, rather than then otherwise you would have not done it, in my opinion. So how it is observability and data engineering related? It's a very simple. Both are like, both data engineering and observability is essentially an observability domain. You can club both together in a different way. Like, obviously the tools and everything is kind of a little different, but the fundamental principle behind it is very same, right? Data engineering, you are observing the business. Like, when the users comes in, they do certain activities, and your product or a business behave in such a way, and you're observing how your business is kind of behave, right, in terms of a sales deals coming in, sales flow coming in. So essentially it's all a workflow, right? Like, your the sales pipeline coming in, new leads coming in, your sales engineer going to talk to them, and there is a step-by-step workflow process. And observability essentially, like, data engineering essentially observe how your data flow goes, how your sales flow goes on, how is your product flow goes on, from a sign up to purchase certain things, marketing, like from origination for a campaign to a successful lead generation. Everything is kind of a workflow that does that, and then you are just trying to observe from a data engineering perspective. Observability, on the other hand, is like there is a request being originated by the user, and then it goes through a series of uh, uh, service kind of interacting with each other's, and then you are producing a final output, which is like a happy, like a 200 or a 500 or whatever the end state that is. In a way, it is also very in a way, it's also in a workflow that observability kind of observing. That's when, like, you see a lot of correlation between, there's something, a long debate in mine in Slack is like, okay, what does it mean for traces? Is traces can be used in the business, in the data engineering space, or it only belongs to the observability engineering? Because essentially in both sides you are observing certain kind of a workflow that does that, and then you wanted to understand where is the inefficiency, and you wanted to understand, and you wanted to optimize that solution, right? That's what the fundamental theme. Especially, only the difference is, like, data engineering is built for the business, where observability is built for the servers and the infrastructure side of it. um, the philosophy remains the same, but the scope is very different, right? Like, for example, your data engineering space, the business session or business scope, like, tend to log at longer window time, right? Like, user session might be like a deal cycle, maybe like a 3 years. Sorry, 3 months or like 6 months. A typical enterprise sales goes on. There is a fundamental difference. The the function it is working, but philosophically, I see observability and data engineering on the same side of it.
Yeah, it almost seems like it is necessary. Like you said, it's like I'm going to build all those things, but in a way, I need to have a view on what I'm building, even more when we scale, which reflect as much of the reality as possible. So my follow-up question on that is, if my understanding is correct, you're more than ever interested in observability. Um, I recently got my Databricks champion title, um, certified data engineer, data science. And so I've used Databricks and like all their tools and data governance and how you can observe your pipelines and so on. But when I think from a project perspective, or I don't know, Kubernetes clusters, pipelines, metrics, dashboards, numbers of pull requests and core reviews, like we can do analytics on so many things, and all of those can be very relevant if observed in the right context. Um, and when I say context, I'm thinking of how to use maybe Gen AI capabilities to like do an extension of all this data, which needs to be correct and well measured in the first place, but to like draw insights or conclusions or infer maybe specific priorities or unique feedback that was only available from a human perspective. So I'm just reasoning a bit out loud here, but I think that my main question is, with everything that is possible in data observability, what have you like? What are you the most interested in, and what do you think that those new capabilities that we can unlock with Gen AI impact observability and data engineering?
Yeah, so GenAI is a very interesting section of it, right? One of the bigger challenge in data engineering space is like, um, if you go to any organization, you will find that there is no dev environment or any kind of a trial environment that you wanted to play, or there won't be any reliable environment available for them to test it out. The reason is that it is not like data engineers don't know how to build the system. It's like crazy expensive for them to do that, right? Like crazy expensive in the sense like the production data is our dev data, right? Like whatever the application that people are accessing and you collect the data, that is often the more reliable and accurate representation of what is the data and the nature of it. The fundamental difference between the data engineering and the software engineering is that you are actually programming the data, and your SQL is just another DSL that you're just expressing how you wanted to process the data, not necessarily you're writing the hard logic on top of it, and then it get transpiled into the actual execution that is kind of happening there. Versus in the software engineering, your programming is where your whole business logic kind of abstracted, your transactions and everything get abstracted. So it's far easier for you to test the code, but you are testing the data in most often in the data engineering space. And where do you get the good test data that is kind of reflecting the real world scenario? And and the other complication is like DAC is like very social in nature, right? You will tend to have like multiple upstream dependency before you just do the work, which is completely different from a request response model that you send the request and you get the response back. And So these are the things becoming make it very complicated for you to reliably test your system, and that's why people are tending moving towards an observability. And the challenge with the observability is that you often will know when certain things are failed, and but the data ecosystem, like data pipeline, will not stop. Right, it just continue run, and you find it out after 24 hours. Oh, there is something problem in the data side of it, and by the time you get it, I've seen most of the cases where the cost of repairing the problem is much higher than you just live with that. That you just say the stakeholders that this data getting is not trustable. This one batch is not trustable. We don't want it to reprocess all the 24 hours data again back. It's just kind of very expensive for us to fix this one. That is how it goes. Like that's why most of the data observability is like non-actionable. It's an actionable in a way, just like, oh, it just happened. Like shit procs, we know that. Just live with that, right? Because I don't want it to spin off another Spark cluster to process another 24 hours data. Right? I think this is where I feel GenAI will play a major role. Ability to build an integration testing environment, right? Like before you commit the code, how can we intelligently build a system that can it's kind of an emulator, right? Similar to what you've seen in a gaming engine, or similarly, like, game development, or Android or any mobile OS development. Before you commit the code, you just simulate what is really happening. I think that kind of a simulation environment is what uh, I believe it is capable right now with. the emerging of a lot of um, you know tools like DB or data fusion, like single node execution engine that's coming in, and the ability of GenAI to provide more and more production look like data into our ecosystem. How do we seamlessly integrate that one to give the capabilities of the data engineers and make the data pipeline more and more reliable? I think that is the biggest impact, I would say, in the data engineering workspace.
I think I'll ask you one more thing about uh, like Gen AI and how um, Andres Carpati talks about the LLM as an operating system, um, which I think is fun, and I think it will integrate very nicely into data engineering. But before I ask you my follow-up question on Gen AI, I wanted to come back to uh, maybe data engineer itself. I really like how you made the distinction between a software engineer and a data engineer. I feel that of all the roles of around like tech and data, those two are not as easy as they seem to like distinguish, because maybe a lot of data engineers end up doing software engineering and vice versa. Uh, I guess it depends on the companies and so on. So I guess my question would be, if you were to guide. So this question is on two level, on the younger people and the more advanced. But people who are taking the path of software engineering or data engineering, um, what should they be curious about? And I ask you both for someone who is getting started and someone who have already 5, 6, 7 years of experience. Like, what skills would you look for? What tools? What technology? What's the mindset to have? I'm sure that you have some insights, and you can also maybe comment about the book that you wrote. But yeah, this would be the main question.
If somebody is starting a career in data engineering, I would say um, yeah, welcome to data engineering. That's how first I would say. I think getting the fundamentals correct is very, very important, right? I think people tend to carry it away, like I wanted to learn DPT so that I learn things. The fundamental is that you have to have a good grips of SQL. SQL is 90% of the data workload, or 95% of the data workload, essentially being expressed in SQL. So mastering and understanding of how the SQL is kind of working, not only from the syntax perspective or the other aspect of it, like kind of understanding how how when you're writing a SQL, how it is kind of transpile that into an execution model. Like if you do a partition, what does that mean by partitioning data? What do you mean by clustering the data? What do you mean by creating an index out of it? So having that fundamental way how the database is kind of working and how the SQL is much more performant in the SQL side of it, right? When I started, started to use Oracle. Oracle has this concept called hinted index. I don't know how many database has that. Like you can hint that to Oracle that I wanted to use this index. So you are expecting to understand what is the underlying distribution of the data. So you have to understand the typical database fundamentals of the distribution of the data over the period of time. Right? I think it's very, very critical for you to write a very well written SQL on top of it. And the second thing is obviously having some proficiency of Python, because not all your data is going to be clean. So you tend to kind of process a lot of unclean data. Python kind of really shine in that space, and then having a good understanding of it and ability to process the data. Um, you know, Practice a lot of processing JSON and CSV data. As much as we like the clean data, or the beautiful architectural data pipeline, the reality is that you will be processing CSV data. That's a curse of data engineering, but you just the moment you start to enjoy it, you'll be fine with that. So I think getting those fundamentals like SQL and Python, how there is kind of processing and ability to kind of understand how to process unstructured data and the structured data, and also also the understanding of underlying um, storage engine, how it is stored, what it means to store good. That is the first fundamental level. I think second thing is understanding some of the data modeling techniques. There are like well referenced data modeling technique. Not necessarily you will need to follow that, but it is good to know that, your star schema design, your Kimball methodologies, what it slowly changing dimension mean, and how do you think about modeling slowly changing dimensions from various different perspective associated with that one. What it mean by activity schema, and those techniques and walking through that particular thing is also very critical for us. So if you know underlying how the database store the data, and you understand the data modeling technique, and you understand how SQL is kind of interrelated, all three are interrelated for you to efficiently write your query to do that one. I think from a technical aspect, I think that's where I would say like pretty important to get the basics of that. Yeah, 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 yeah. Yeah, great. I think before that, like you mentioned about the real time, non real time side of it, I think that's a very easy way to figure it out. Like you just need to ask your stakeholders, like, if I build this in real time, is there a human in the loop to make a decision in real time? Then, if the human in the loop, you don't need a real time because none of the humans can react in real time. I don't think anyone build a system that a human will stare at the screen and then making, oh, this looks good, I'm making a decision. Like that's not going to happen. And unless and until there is a machine making a decision, you don't need a real time. We are not capable of real time decision making. Um, um, and then like on the experience side, engineer side of it, I think by the time you kind of well versed your technology and other things, it's important to kind of understand the domain. Like the best advice that I got, a couple of advice I got in my career, especially on the data engineering space, is like one is like, your career is not a ladder to climb, it's a cycle. And never afraid of bootstrapping on your own. All right, I think um, experience, like one of the thing is I would always encourage data engineers, like don't pick a specialization too early. Explore a lot and then pick your specialization and really see what you like it about it, right? So what will happen if you're specialized early, then you don't get the breadth of the ecosystem that is available. And understanding that perspective is very very important. That's why if you see people are majored in a different discipline, like biology, physics, or mathematics, do much better than computer science because they have a different learning, and then they're trying to map that concept into their own practice. You get a very fresh perspective, and that is where the innovation happens, right? Explore a lot, don't pick a specialization very early. The second thing is like, um see the real world. One of the other advice I got, like when I wanted to I kind of carried away with the Hadoop, and I wanted to now understand the data modeling, and I was reaching out to one of my mentor. So he mentioned a very simple thing, like, okay, go to Walmart or go to any supermarket and see from a data engineering perspective what you are observing, you know, and come back and tell me, not as a person or not as a shopper, but as a data engineer, you go to a shopping mall and see what you are seeing. When you started to think like the real world with from a data perspective, oh, I will collect this data, oh, this I will organize this rack in this kind of way of a data structure, and oh, this particular the shopping the supermarket tend to charge for the brands if you're placing in a very visible area, right? So oh, then I have to place the rack, right? So once you started to kind of really see the real world and walk around and then kind of understand how you model the real world, then your perspective will broaden, and that is where you will get a deeper understanding to your domain, what you are working on. So that's a one technique for you to kind of thinking in terms of a domain expert. So when you started to see from a domain perspective and bring that experience back into your data engineering skill, you will be very, very efficient in what you are doing.
Awesome. I like this one because it forces you to constantly be applying your concepts and trying fun ways to, or metaphors or comparisons to apply these concepts that you're learning into the real world. Yeah.
Yeah, but word of caution, like don't do that on your dating life. It
Yeah.
will be it will be disaster for you. I can
Uh,
guarantee that.
maybe there is a way to do this right, where you can
No,
even do
don't even think about that.
it. All right. Noted. Well, amazing. Well, I think that we're running a little bit out of time, so I would have like the two closing round questions for you. But before going there, I want to thank you very much for answering all these questions. I'm having a lot of fun, and I could go on for hours asking about these things and with the kind of experience that you have. Um, maybe before asking those two questions, well, the first question of the two is like, where can people learn more about you, your book, everything that you're doing, and also your current work, and posts and everything that you're doing? Maybe you can share some information regarding that.
Yeah, the best way to follow my work is on obviously like we talk about what data engineers to do to kind of learn. Like one of the things is like read Data Engineering Weekly. Not because I write. I think one of the things is like Data Engineering Weekly. What it does that it kind of curate what is happening in the industry last week, right? It kind of create what good work people have done and then kind of publishing this one. If you started to follow Data Engineering Weekly, regardless of you're a fresher or a experienced person, you will slowly get accumulated to the pattern that people are solving the problem. Often that's the best way to learn, and that is how I learn. So I write Data Engineering Weekly for myself because I wanted to learn things and how smarter people are solving the problem. I'm just like a reader perspective, right? So I think that's a good thing to kind of do that one. So you could typically follow me on Data Engineering Weekly to get this one.
Awesome. I'll just do a follow-up question on this one, which is, when we say data engineering, do you have in mind also like the architecture part of it, like being a solution architect? Because I feel like when you're very curious and you just want to build things and try to, I don't know, build things that add value, and then you're maybe leaving a little bit the data engineering space, or like, I don't know if you, we mentioned before Kubernetes clusters to scale resources. So I know a lot of data engineering should have this in mind, but it also seems that a lot of the time the roles associated to the resources and like having Terraform and CI/CD and unit testing, or I don't know, all these kind of things. Would you put them as in the learning path of the data engineering, or would you say that as a data engineering, it's very good to like broaden your skills and have more visions and perspective on what you can do? Maybe a little bit of front end, maybe a bit of software engineering, maybe a little bit of clouds and architecture and cloud providers, and not only like moving data, but also knowing very well like machines performance and your CPU and monitoring and all these kind of things.
Yes, I think you should understand like a broader scope of it, right? Like because end of the day, even though you are running a SQL or any other aspect of it, it still has to run on certain kind of a machine. So it is important for you to kind of understand what is happening behind the scene, just not like the abstract layer that is what is providing to you. If you, as develop like we love to build more and more abstraction, right? That's the one like we wanted to build more and more abstractions on top of it. But like if you are a learner and then you just isolate your learning curve only to that abstraction layer, then when that abstraction kind of fail you, you will not able to understand what is happening in the layers below, and the new abstraction changes. Now you have to have a whole new learning curve how the another abstraction going to work from a Hadoop MapReduce world to Spark to other world. But if you see the underlying layer in Spark is also the way that solving the SQL is a kind of a map reducing model, right? There is a very subtle difference between RTT and the way MapReduce kind of working behind the scene. So it is very important to kind of understand the underlying layer, because the abstraction always changes, might change. But if you know the underlying layer, you will be much more efficient into doing that one. And the second thing is on the CI/CD. Like even though we are doing a data engineering, there's a difference between the software engineering and data engineering. But we are still building a production scale artifact, which is what the software engineers does. That an artifact that get delivered and build this one. So you should also follow the same rigorous what the software engineering kind of bringing in to build your data model to make it production ready. That brings your unit testing, so the unit testing and CI/CD pipeline is all a feedback loop, right? When you're building an application, unit testing is the leftmost side of the feedback loop, whereas your blue-green deployment is the rightmost side of a feedback loop. Understanding like how different stages of a software engineering artifact get deployed and then make it more reliable, we should know and we should bring that into the data engineering practices.
The last question is, and I want to thank you again for coming on the show and sharing your extensive knowledge and experience. There are a few things that we could dive deeper on other episodes, but overall, I'm super happy with what I was able to learn and ask. So the last question is: do you have a message for the Let's Talk AI community? By a message, I mean it can be anything. It can be like an inspirational moment where you just say why it's important to go for data engineering, or things that you've struggled in your career. It can be personal, professional, whatever you feel like sharing.
It is a very interesting time to kind of enter into data engineering. So don't hesitate, like don't get carried away from any other AI technologies. My theory is that if you see the industrial evolution kind of happen over the period of a time, especially the textile manufacturing side of it, from a hand looming to a machinery is kind of making. Obviously, hand looming kind of uh, gave away with the industrial scale manufacturing. But we manufacture a lot. We employ a lot more people, but it's a different skill set completely. And then we still manufacture a lot, right? We still the fundamental need going to be remain the same. Same way, the Gen AI will accelerate the way that we are building the data. The more and more industries will start to use data. Otherwise, if you are doing a hand stitching of all the data modeling, may not be possible. So you will see a huge demand more and more. It's just a different way of workload. That's when going back to my, the previous question answer, like, understanding the importance of underlying layers is absolutely critical for you, because you mentioned about LLM as an operating system. That's another abstraction. When an abstraction changes, the whole construct around that is kind of going to change. So keep the focus on the fundamentals. You'll be fine. There'll be a lot of exciting opportunities to be ahead for you.
That's awesome. Thank you very much, Anand. I wish you to have an amazing day.
Thank you so much. Appreciate it.